Now we mentioned back on the first page that if D is equal to 0 or is undefined, I should have underlined that, then the test is inconclusive. And we backed that up over here in the table, right? So if it's 0 or undefined, it's inconclusive. So let's look at some examples of what inconclusive can look like. So we're going to find the critical values and show that the second derivative test is inconclusive. And then can you see other indicators to determine whether the critical value is a maximum, minimum, or saddle point? Okay, so let's find the critical points first. Let's see here. Fx would be negative 4x cubed, and Fy would be negative 4y cubed. If both of these are equal to 0 simultaneously, the only way that could be possible is if x was 0 and y was 0. So the critical point would be 0, 0, 2, right? Okay, so let's run the test and prove that it's inconclusive. So to do that, we need fxx, which would be negative 12x squared, fyy, which would be negative 12y squared, and fxy, which is 0. Putting them together, D is fxx, fyy, so that's 144x squared y squared. Take away 0. In other words, it's just 144, or 0 squared, if you will. So it's 144 x squared y squared. All right, now if I put 0 into this, 0 and 0 into this, I would have, right, at 0, 0, 2, D is equal to 144 times 0 squared times 0 squared, which is 0, which is inconclusive. All right, so let's think about this logically. If we look at the function f of xy, and that's 2 minus x to the fourth minus y to the fourth, we know that if I put 0 and 0 in here, that's the lowest we're ever going to get for a value, right? It's the largest possible value. In other words, this is kind of bowl-shaped downward, if you will. Sort of like how a parabola faces down, but this is two-dimensional. So it's, let me put it this way. It's a bowl shape facing downward. So 0, 0, 2 is the maximum. Now we can back ourselves up with a graph here just to see if what we're thinking here makes any kind of sense. So let's look at it. Here it is. So I've graphed this function and you can see 0, 0, 2 is the highest this graph ever gets. It's where that little red dot is there at the top, right? So that's 0, 0, 2. So it's a downward facing shape. And so the highest it ever gets. So indeed it is a maximum, even though our test was inconclusive. All right, what about the second one? Okay, so 2 minus xy squared. So let's find the critical points. Fx would be negative 2xy. Oh no, that's fy. Sorry, fx here. Fx would be negative y squared. Fy would be negative 2xy. There we go. Okay, now I want to set both of these equal to 0 simultaneously. Well, again, the only way that's possible is if x is 0 or y is 0. And if y is 0, that's going to make this other one 0 as well. So the critical point would again be 0, 0, 2, in fact, because if I put 0 in there, I'd have it be 2. All right, so now let's run the test. So fxx is 0, right, because there's no x left in this. Fyy is negative 2x. Fxy is negative 2y. putting that together, d is 0 times negative 2x minus negative 2y squared. So in other words, it's negative 4y squared. Now, if I substitute in 0, 0, 2, I would get negative 4 times 0 squared, which is 0, which is inconclusive. All right, well, logic isn't going to help us as much with this one. So logic helped us with this one because they were both to the fourth power and they're just subtracted. So it's pretty straightforward. This is the highest it's ever going to be. Whereas on this graph, they're multiplied and they're not necessarily positive. So we don't really know what this is going to look like in our heads. So logic isn't going to help. Not the way it did for the other one. The other one was so easy because x to the fourth and y to the fourth were both positive and they were added. So if I say it's because of x times y squared could be positive, comma, negative, comma, 0. You know, we just don't have the clear answers that we had over here. X to the fourth is positive, y to the fourth is positive. So when you subtract them, right, it's going to be really easy what's happening. Whereas in here, not so much. So we're going to have to look at a graph. All right. In Maple, I have a graph here. All right. And so actually, there's a whole bunch of points along this line right here. And we have saddle points, right? So 0, 0, 2 is a saddle point. As a matter of fact, there's a whole bunch of them because back in the critical point section, if we did 0 and 0 and 2, we got that. But this y equals 0 has any x at all to go with it. So, and same thing with this one, right? So these y equals 0s, I could put in 2 here, 4 here, 7 here, 14. There's actually a whole bunch of critical points. So it's any x and then 0 and then 2. Because any x at all would have made, or excuse me, any x times any y that's 0. So x times 0 will always be 0. It doesn't matter. So that means that there's actually a whole bunch of saddle points, more than we first realized, right? There they are all lining up in a line. I just put in a few of them, but there's actually an infinite line of saddle points, right? I put in 0, 0, 2, 1, 0, 2, negative 1, 0, 2, 0.5, right? All of them are saddle points. They're all where it's changing concavity there. So look at the graph, and what we see is that any x, comma 0, comma 2 is a saddle point.